Hello everyone, we are now at a new chapter about security. In this chapter we'll talk about some basic about cryptography and then how we use cryptography to encrypt and decrypt messages. So basically this is to ensure the confidentiality of the message. But then there is another use of cryptography, which is to check the integrity of the message. We'll talk about this later. And also there's another aspect of security called the authentication, which we will talk about this a little bit. Alright, after that we'll see how the security is applied through all the layers in computer networks, starting from the applications and then transport layer, network and link layers, and then finally how the security is used in practice, for example by using firewalls and intrusion detection systems or prevention systems. Alright, now let's start with the introductions. So when we talk about security, there are three important aspects that we have to let's say this is some people say this is the objective of security, and the three aspects is also well known by the CIA triad. C is for the confidentiality, I is for the integrity, and A for the availability. And then okay, there is another aspect which is not part of this CIA triad called authentication, but it is also something quite important. Okay, so what is confidentiality? From the name itself, we already know that it is an aspect where there is, the message is only known by a particular parties, okay, for the communicating parties. So it shouldn't be revealed or shouldn't be known by other parties, right? To apply or to ensure this confidentiality, normally we use the encryption and decryption techniques. Alright, so for the integrity, so basically we want to make sure that the message is complete, it's not changed, there is no deletion, it's not deleted, it's not added, inserted by by anything, and so on. This is very important. Let's say if we are doing some online transaction, so we don't want that our transaction is changed, the number is changed, and or we are sending a very sensitive message to, let's say, headquarters and so on and so forth. Okay, and then the technique that is used for ensuring the integrity, one of these is called the digital signature. And then the third one, availability, is basically how to ensure the service should be available when it is needed. Alright, and then one important or one very common attacks to, let's say, to make this these aspects or to make the service unavailable is called DOS or DDoS, or denial of service attack. Or let's say simply have the server down is also a violation of availability aspects in security. Okay, and then the fourth one, authentication. I think this is also quite familiar by all of us. When we want to enter into let's say a website or any application, we have to provide our username and password. That's one form of authentication. So basically what authentication does is to confirm the identity of a user or specific person. Okay, so apart from login with username and password, there can be any other method, like for example biometrics, or by using smart cards, or by using a token, and so on. Alright, so there are different ways of authenticating. Okay, now in the security world, there is a well-known model that is used to illustrate the security. First of all, we have Alice and Bob. So this Alice and Bob, let's say they are lovers who wants to communicate securely. And then there is third person. Let's say we can call it Trudy, or in some other let's say in some other model it is called as Eves or eavesdropper. So this Trudy may intercept, delete, or add or insert something into the message. Okay, now in real life, what this Alice and Bob be? They might be web browsers and web servers. Let's say if we are doing some online transactions in e-commerce websites, or online banking client and server, DNS servers. As we know that DNS consists of several distributed servers. So the exchange in let's say DNS record, this among the servers that can be Alice and Bob. And also when we study about the routing protocols, the routing needs to exchange the information about routing tables to the neighboring routers. So this can be also the Alice and Bob in real life. And there are many applications or many examples of Alice and Bob in networks. Now, what can a bad guy do? So basically, in security terms, this is called attacks. Okay, so what are the security attacks? So there are many types of attacks but we are trying to summarize into let's say 5 points. The first one is called eavesdropping. So eavesdropping is basically intercepting message, or basically just to listen to the communication, what's happening in between communicating parties. Let's say if we are talking about the hacking step, this is the first step, and this is very important because we want to gain as much information as possible, right? Before we want to do the next steps. Okay, now there is also insert message into the connection. This can be just to, let's say we can insert information for the online transaction, for example, or we want to add some information. Let's say if we are sending very critical message to the headquarters. Let's say if there's a war, and then the one in the field wants to send a very important message to the headquarters. If we just change the message, this can be devastating to this party. Or it can also be like in our, let's say, everyday life. It can be a script that will direct the communication to the bad guy. All right. So this bad guy can obtain your private information like banking information, credit cards, username and passports, and a lot of other information. Okay, and then the third one, impersonation. If we talk about the IP address impersonation or MAC address impersonation, this is also called spoofing. So basically, this is used to. There are many purposes of using impersonation, but one thing is we want to hide our identity by using this impersonation. And then hijacking. So basically, taking over the ongoing connection or session. So for example, like when you are having a session with the remote server, and then someone is hijack your communication, your sessions. So now you are no longer having control over your server, but then this bad guy having control over your server, and then he can do many things with the server. So that's very bad. Also, like for example, if you are controlling your drone, and then someone nearby is taking over the communication, so now you're no longer having control to the drones, but this bad guy does. So he can do anything with your drones. So that's some examples of hijacking. And then the last one is denial of service, or the variation of this is called distributed denial of service. So basically, this is an attack that is aimed to let's say make the service unavailable to the users. And there are many methods, there are many ways to do that. So basically, it's trying to overload the resources. It can be CPU, memories, bandwidth, and so on and so forth. So that's some basics about the security that we have to know. Now we're going to talk about the cryptography. But just some reminder or some simple notes to begin this before we start with cryptography. In this discussion, we're not going to, let's say, go deep into the algorithms of the different cryptography techniques. We are just going to give the principles. If you want to know the details about the different cryptography schemes, I suggest you to take the cryptography course. Okay, so before we start, there are several terms, there are several let's say notations used in this cryptography. So first of all, we have the plain text. So basically, this is the message that we want to encrypt. So this is the original message, let's say. And then Alice wants to send a plain text message to Bob. So, and then Alice doesn't want the truly to get what is the content of this message. So Alice has to encrypt this plain text by using Alice encryption key. Let's say it's called KA. And then the result of this encryption is called ciphertext. Okay, so although Trudy can obtain the ciphertext, but without knowing the Alice encryption key or the decryption key, Trudy will not be able to get the content of the message, the original content of the message, right? Now, Bob, the destination of this message has the decryption key. So, okay, we're not talking about the different scheme of the encryption, encryption scheme right now. Let's say the Bob's decryption key KB is able to decrypt the message sent by Alice. So now Bob can recover the original plaintext message, right? So the notation we will use normally, M is for the plaintext message, and then KA is for the Alice encryption message, and then if we combine this together, KA and then bracket M, this means a ciphertext. So message M is encrypted with the key KA, and then the result of the decryption process, we can have this. This is basically the ciphertext. The ciphertext KA M can be decrypted by KB, so it will result with into the original plaintext M. Okay, now there are two, let's say, basic cryptography schemes called a symmetric key, and of course there is another scheme called asymmetric key or public key cryptography. So we start with the symmetric key because it is the simplest one. So basically, in symmetric cryptography, both Bob and Alice share the same or symmetric key, let's say KS. Okay, so the requirement of this scheme to work is both Alice and Bob should have the same key, so that they can communicate securely. But this is the key issue in the symmetric key cryptography. So how Bob and Alice agree on the key, right? In real life, it is very difficult because if we want to share a key, it has to go through some kind of medium, and then it's not become secret anymore. Let's say we can send it by email, but then or by a message, then it's not secure anymore. I mean, it's not secure anymore. So this is something that will be addressed by public key or asymmetric key cryptography. Alright, okay, before we talk about the asymmetric or public key cryptography, we'll talk about some scheme in the symmetric key cryptography. The simplest scheme, it can be called substitution cipher. Actually, the cipher is very old. Let's say if you read old novels or maybe old movies or watch old movies, you can find this kind of encryption scheme. So basically, the idea is you try to map the alphabet with another set of alphabets. This another set of alphabets can be shuffled or randomly ordered. So, for example, in this slides, the alphabets A, B, C, D, E until Z is matched with another ciphertext M, N, B, V, Z, X. So A is matched with M, B with N, C with B, and so on and so forth until Z with Q. Okay, the key to understand or to decrypt this scheme is to understand the patterns. So basically, you have to guess. You have to make a lot of guess. What is the actual words? All right. So for example, in this case, with this encryption scheme, okay. Let's say we have the plaintext Bob, I love you, Alice. So this can be encrypted into Bob into NKN because Bob B is matched with N, O is or substituted by K, and then I is substituted by S, right? And A by M, L by J, and so on and so forth. So we have this NKN S GKTC blah 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 as the ciphertext. Alright, now in real life, what we have now, especially in for the network or internet, the first symmetric key cryptography or algorithm or standards that is launched out there is called DES, Data Encryption Standard. This was issued by NIST, 1993. It has 56 bits key and 64-bit plain text input, so it's not flexible. If we have more than 64, we have to break it down into 64. Okay, so now the most important thing is how secure is DES. Okay, so if we brute force this 56-bit key DES, it can be broken in less than a day. Okay, so this is, of course, it's not preferable now. Okay, to make the ES more secure, there is an attempt to make it 3 times. So the encryption process is done through three times with 3 different keys. It is called as 3DES. But of course, this it becomes more complicated. Okay, then now let's say the state of the art symmetric key cryptography that is used is called AES, Advanced Encryption Standard. So this is replacing the ES. It processes data in 128-bit blocks. But actually there are different modes in AES, CBC, EBC, and so on. So you can learn in cryptography class. And there are different sets of key lengths from 128, 192, 256. And then this is the most important thing. If we compare between DES and AES with the relative comparison, if we can, let's say, break the DES in 1 second, it takes 149 trillion years for AES. So okay, so let's stop now. We'll continue again next time with the public key cryptography.